Alright, so some of you asked me to go over the gas law practice sheet, so I'm going to try to help you out with it. The biggest hurdle for a lot of you is just reading the problem. Once you can read the problem, you can find the correct formula to use, and once you find the correct formula, it's really not that hard. So I'll solve the ones you want me to solve, and I'll help you with some of the other ones. So the first one, you start looking at what we have. We have liters and pressure, and I have pressure, and I want liters. So I have volume and pressure, and I have a pressure, and I want a volume. So that has to be Boyles, because Boyles is P1 V1 is equal to P2 V2. All right? And so Boyle, I don't know how to write that. Okay. So second one, same thing. I have P1, P2. I have, oh, actually those are not P's. Those are T's. So T1, T2, and I have P1, and I'm asking to find P2. So if I have pressure and temperature only, it's got to be K to the 6. So that's how you read them. The third one, I have a V1, I have a T1 at constant pressure, so I don't have to worry about pressure. And then I have V2, it's asking me for T2. Alright, so if I have V's and T's only, it's going to be Charles. I'm going to spell Charles right. Number 4, I have P, I have T, I have V. It's asking me for N. There's only one set of conditions, right? So the sense of one set of conditions has to be ideal. Right, so number 5, I wouldn't worry about number 5. I didn't give you that law, and I didn't kind of realize it was here. But really what it's asking you to do is molecular weight requires STP. Right? So the way you would set this up, P1 and P1, 6.7 liters. I'm going to put my 6.7 liters has a mass of 47 grams. T1 is 245K. Is equal to, we're going to go to STP, so 1 ATM. I've got 22.4 liters per X grams divided by 273K. Right? So when you get the answer to this, just go to that, you're going to get grams to -1. So if you use the x to the -1 value when you get your answer, you get the correct answer of 51. All right, so this is kind of a combined. It's really Avogadro's law, but we didn't go over Avogadro's law. So anyway, so where were we? So 6. Someone asked me to solve 6. So I'm going to erase some of this so I can clean this up a little bit. So for 6, an ideal gas occupies 400 milliliters. So I have a volume, I have pressure, and I have temperature. Is changed to pressure and temperature, and it's asking me for volume. So I have all 3 variables, so it's got to be combined. I have P, V, and T. So my formula is P1, V1, T1 is equal to P2, V2, T2. right? So I start substituting in. So my P1 is 270 65 Celsius. Remember, I have to change that to Kelvin, so that's 338 Kelvin. Remember, it's 273 plus the 65. And my V1 was 400. Is equal to P2. So I have 1.4 ATM. So I'm going to change my ATM to millimeters of mercury. So when I do that, I get 1100 millimeters of mercury, because I'll keep the 2 digits, times V2, which is I want to find, and my new temperature is 373. Okay. All right, so I'm going to set it up like this. All right, so that's my problem here. All right. So when I do that, I'll get 100 millimeters. So a lot of these, the answer key doesn't go to significant digits because this has 1 digit, so I really have to have 1 digit in my answer. You get something like 10 something. Okay, so if I leave it at 1 digit, I round it to 100 milliliters. 7, just so you know, is ideal. 8 is ideal. With 7, remember the 23 grams. You have to convert to moles first. 9 is ideal. 10 is combined. 11 is combined. So 11, actually the answer key is incorrect by a factor of 10. So it's combined. So remember, combined is going to be my P1, V1, because I have 3 sets of conditions, right? I have V, P, T, and I'm going to convert to STP. Remember, STP is 0 degrees Celsius and 1 atmosphere. Okay, so I have 5 ATM times 200 liters. I convert my negative 140 to Kelvin. I get 133 Kelvin is equal to 1 ATM V2. When I get this, since I only have 1 significant digit with the 200 and the 5, I will round that to 200 liters. It really comes out to 205, but I have to round it to 1, so it's 200. Okay. 12, someone asked me to solve 12. So 12, I have a P here, I have a T there, I have a T there, and it wants a P. So P and T, so that's Gay-Lussac's. Because I only have P's and T's. So my formula is P1, T1 is equal to P2, T2. All right. So my P1 is 1 ATM. My T1 is 100. So, oops. So I'll change that to 373 Kelvin, because I got to go to Kelvin first. P2, and then T2 would be 438 Kelvin. All right, so when I do that, I get 100 ATM. Hold on a second. I get 1 ATM. In actuality, you'll get 1.17, but I have 1 digit here, right? So I'm obligated to go to 1 digit there. So it should be about 1 ATM. You solve it. 13 doesn't require a gas law. 14 should be Dalton's. Remember, got to make this ATM first. Right? So remember, ATM is equal to 1 divided by, oops. So the conversion from kilopascals is 1 ATM over 101.3. So if you multiply this by that, you'll get ATMs. And all these are ideals. The only one someone asked me to solve was the first one. Remember, ideal gas law is P. Oops, I don't know what I did that. For gas law, PV equals nRT. Right? So I'll just go in it. So pressure, 5.6 ATM. My volume is 12 liters. Equals 4 mole. R, so R is 0.0821, and that's ATM liters moles Kelvin times T, because we're trying to find T. So when I isolate T by itself, I get 2.0 times 10 to the 2 K. So that would be my answer. I really get 20 something, but actually I have only 1 digit here. Oh man, this is messing up. So really, my answer should be 2 times 10 to the 2. Okay. Right, because I can only have 1 digit. Or, since I have 1 digit, you could write 200K. The pen's running out of battery. Okay, so I hope that helps out, and good luck on the quiz today. I won't make it hard, I'll make it as easy as possible.